Exponential functions. Basic definition of the exponential function is that f of x is equal to b to the x, or you can say y is equal to b to the x, and notice that x is an exponent. That's what's going to get you into trouble. B is the base, and the base has to be positive, can't be 1. X can be any real number. Now, if x can be any real number, what that means is the domain of this guy is all real numbers. And that has to be true. You take a look at this. As a constant raised to a power, that's x. That's where your x is. No denominator, no radical, all real numbers. So examples, of course, is 2 to the x, 4 to the x, 5 to the x plus 1. And if I want to do a graph of a basic function, this would be y equals 2 to the x. His domain is all real numbers. That means that if I were normally to try to graph this thing, if I were in intermediate algebra in particular, I do -2, -1, 0, 1, and 2. So this would be 2 to the -2, which is 1/4, 2 to the -1, which is 1/2, 2 to the 0, which is 1, 2 to the 1, which is 2, 2 to the 2, which is 4. We might have been able to go a little bit bigger on that. So -2, it's going to be 1/4, 1/4. -1 is a little higher than that. It's 1/2. 0, 1. 1, 2. 2, 4. And if I just connect the dots, it looks like this. It's going to continue up. Now, if you remember something about the exponential function, it has a horizontal asymptote. So it has an HA at y equals 0. That's the basic function. Which means that the domain of this guy is going to be 0 to infinity, not including 0, because it's the horizontal asymptote. Now, if I look at trying to deal with f of x is equal to 1/2 to the x, the base is now 1/2. So again, the domain is all real numbers, so that's going to be easy enough. So if I do my T-bar chart, so -2, -1, 0, 1, and 2. This would be 1/2 to the -2. That flips it and squares it, so it's 4. 1/2 to the -1, that flips it, that's 2. 1/2 to the 0, that's 1. 1/2 to the 1, that's 1/2. 1/2 squared is 1/4. So now I look at -2 is 4. -1 is 2. 0 is 1. 1 is 1/2. And then 2 is 1/4. So he's flipped around the y-axis. He's going to continue going up. And again, I have an HA at y equals 0 because he's basic. And so his range is 0 to infinity. And we know that in this class, one thing for sure, domains and ranges always play a role. Domains in particular, not so much ranges, but domains play a role in what we do because that helps establish the infamous number line.